Okay, let's start the solution to homework 4. The first thing I'm going to do is add my name and the assignment. So I use a text box. Don't just start typing it, or it'll enter it as an equation. So just type my name, ECHE 101, and this is homework 4. All right, then I can click off and actually start the math. Let's go ahead and get all the preliminary information in. So first, the critical pressure. Now I can hit subscript, or I'll notice when I hover over this, the subscript shortcut is Control plus or minus. So for subscripts, we're going to use the minus. So Control minus C colon 1128 followed by 1, 2, 3, 4 zeros, and this is in pascals. It's important that you put in the units. So again, MathCAD is great because it tracks units, but the downside is that you better put units in or it'll mess up your equation. So let me move that down slightly. All right, next to that I'm going to put T C, the critical temperature, and assign that to 405.5, and again I'm going to put in Kelvin. Under that, the gas constant, which has units, that has a value of 8.314, and what are the units for that? And you always have to be careful whether you're up in the subscripts or not. I'm gonna, whoops, make that a fraction, moles times K. All right, and again, I'll move this around so it looks nice and doesn't overlap. And I use 2 lines just so this doesn't get real long. Omega, I put in a symbol and assign that to 0.25 millunits on that. Now also, if I want to move this whole thing down, I can drag and capture all of that and then move that with the arrow however I want. So that can help you make this look a little nicer. All right, then I can start. Then I can enter A, and that's going to have a value of 0.42747 times R times T underscore C squared. Again, highlight that, divide by P subscript C. And I'll arrange that a little bit. All right, then I'm going to go ahead and type B and M, and then we'll continue from there. Okay, you can see I added A, B, and M, and I rearranged it a little bit so it all fits nicely on the page. And then I've added my first temperature, T1, and let me add my first pressure range, P1. So again, you can just use T and P and then repeat it, but it's probably best to use subscripts for each of these 3 temperature pressure combinations. As I indicated in class, that can cause a problem when you're referring to different pressure ranges that has the same variable. So anyway, piece of 1. assign that to, and now I'm going to do a range of values, not just one value. So 1, make sure I have my units, atmospheres, and then comma, and then that's going to prompt me for two things. The next value, I'm going to put 2 ATM, and then the final value, 9 ATM. So that gives me a pressure range from 1 to 9 in increments of 1. So I'll go 1, 2, and then up, dot, dot, until I get to 9. Then I can start typing my equation. I'm going to call it SRK underscore 1 for the first one, and assign that. Whoops, forgot. And that is a function of P1, and I'm going to be varying V in my root function, and I'm going to assign that to the root of R times T1 divided by V minus B minus A. And let me just continue this offline, but I just make sure I type that equation in properly. Okay, I started my root function, added some of these, most of this equation in. We can see there's a problem, and I can immediately see one of the problems is I forgot a multiplication sign between the m and the parentheses, so make sure you check that. And then I need to get to the end here and finish my equation. Minus P1, because remember I brought the P over to the right hand side, and that is going to be a function, or I'm going to be varying V to find my root. Alright. Then I can calculate my ratio, and I'm also going to give that a ratio 1 to differentiate the three ratios, and right away I can put the parenthesis. I don't have to do any spaces. P sub 1. And I'm going to assign that to SRK 1. And every time I call this, I've got to indicate what is it a function of. It's a function of P1. And I've got to give it an initial guess. In this case, the initial guess is going to be the ideal gas law. And I'm going to divide that whole thing, by the ideal gas law. And again, remember to put in all of your subscripts properly. It's a little overlapping, so let me move that down. And this might be a good time to check whether I've done everything right. So let me ask the computer what is in ratio 1. And I can't just look at ratio 1, I've got to look at it as a function of P1 equals. And we can see it calculates it a number close to 1. It's exactly 1 at the ideal gas law, and it's getting smaller, so at least it looks correct. So let me get rid of that, and I can do that by just dragging this over, highlighting it, and getting rid of it. Alright, so I've calculated the root of the real gas equation, and I've calculated the ratio of that value relative to the ideal gas law. So let me now move on to the different temperature and pressure ranges. Okay, to repeat this calculation 3 times for the 3 different temperatures, I don't want to have to retype everything in, so let me grab the part that gets repeated. All right, and again, I can just drag off to the side and pull up, and once I've highlighted everything that I want to repeat, I'm going to hit Control-C for copy, and then paste and paste. So now if I look at this, I've got this in there. Oh, I guess I only have it in there once. Let me paste it one more time. Add some control or some character turns, and here I have repeated this 3 times. And now I'm just going to go back and change my 1s to 2s and my final pressures to change the 9 to 60 and so on, my temperature to the next temperature. So let me do that and be right back. Okay, I've changed all my subscripts in these sets of equations to 2 and made my maximum pressure 60. Again, there's lots of 2s to worry about, so make sure you carefully go through that and get all the 1s changed to 2s. This is where using the shortcut of Control- can really help. And then, of course, on the 3rd one, change the temperature to 250 C and changed all my subscripts to 3 all throughout and made my maximum pressure 100. So once again, be careful that you make all those changes. Once that's the case, you can check these again. You can look at them. But once everything looks correct and I'm ready to plot, I can go to the plot up on the top and insert a plot, an XY plot, and that'll appear here. And then I can go to my y-axis. I'm going to want 3 traces, so let me add 2 more traces, and then let me type that in. What I'm plotting is the ratio, so let me type ratio, and of course it's a subscript of 1, and it's a function of p, and I don't want to put that into the units. In fact, there's no units on this. The ratio is unitless. So right after I enter the subscript 1, I can immediately enter the parenthesis p under subscript 1. And then I can repeat that. Again, nothing in there under units. Ratio 2, immediately parentheses P2, and then ratio 3, parentheses P3. Does that look right? 1, 2, 3, no units. Now I go to my y-axis. Once again, I need to add a couple traces, and ratio 1 is going to be a function of P1, and that does have units. I want that to be in atmospheres. It's going to, the default will be pascals, and it'll be a very messy axis. Ratio 2 is going to be P2, also in atmospheres, and ratio 3 is a function of P3, also in atmospheres. And there we have it. Now I have my 3 traces. I can write an explanation once again by going to my text box and explain that the ideal gas law is valid. In other words, when this ratio is close to 1, that means the gas is behaving ideally at low pressures or high temperatures. So if I increase the temperature, this ratio gets closer to 1. And that's it. That's all I need to do, and I'm done with homework 4.